Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 1 from the October-November 2016 Pure Mathematics P1 paper from Cambridge, the 9709 syllabus. This is paper 1, variant 3. And this is also question number 6 from my end of topic worksheet from my Pure 1 collection of Cambridge worksheets on quadratics. And this question was a question that one of my students has asked me to answer, so I'm doing so. So here we have a question that tells us about, or tells us to find the set of values of k for which the curve y equals kx squared minus 3x and the line y equals x minus k do not meet. So obviously k is a constant. We have to find the range of values for which this this curve, which is obviously a quadratic curve, is in the form of ax squared plus bx plus c. And this line, this is a straight line, y equals x minus k, is in the form y equals mx plus c. So where these do not meet. So if we want to know about the intersection between these two, what we do is we replace or we substitute one of them into the other. So if I take, for example, this y here, if I take this y over here and I replace it with what y is equal from the other equation, okay, then that's like substituting one equation into the other. Okay, some people say equate the two. Well, that would work in this case, but sometimes when you have something like x squared plus y squared equals something, and y equals something else, then it doesn't quite work equating them. It makes things very complicated. So it's much easier to just think about this in terms of substituting one equation into the other. If your mind is set on that, it makes every question that you might find of this type very simple. So we're just going to basically substitute, instead of y in this equation, kx squared minus 3x from this equation, because the y is equal to that. So I'm going to do that. So I have kx squared minus 3x is equal to x minus k. So the solutions of this equation tell us about the intersection of these two functions, this line and this curve. So I'm going to rearrange it so it's in the form of, as we can see, it's a quadratic equation. So it's going to be of the form ax squared plus bx plus c equals 0. So if I rearrange it, I have kx squared minus 3x minus 1 more x is minus 4x, and add k to both sides, plus k is equal to 0. So this is a quadratic equation of this form, and to solve this quadratic equation, one of the things we can do is we can use a quadratic formula. Now I know that we want to find the set of values of k for which they don't meet, which means this should not have any solutions. If you're going to find the set of values of k for which there will be no solutions for this, that would mean that they don't meet. If there's no solution for the intersection of these two, it means they don't intersect. Okay, so that's what we have to do. Now, what we should understand is that a quadratic equation can be solved by using the quadratic formula, which is x equals minus b plus or minus the square root of b squared minus 4ac. all over 2a. Now, the part of this quadratic equation which helps us to determine how many solutions there are to a quadratic equation is this part here underneath the square root sign. This is called the discriminant. The discriminant, which is given the symbol like a triangle, discriminant. And the discriminant is b squared minus 4ac. Now, if the discriminant, if b squared minus 4ac is a positive value, if it's greater than 0, then you have minus b plus or minus something over 2a. There'll be something there which you'll have minus b plus something over 2a and minus b minus something else over 2a. So you'll end up with two different solutions. So when b squared minus 4ac is greater than 2, it's greater than 0, you have two solutions. You have two solutions. Okay. However, when b squared minus 4ac is equal to 0, then you have minus b plus or minus, and you'll get the square root of 0, which is 0. So you end up with just minus b over 2a. Here is when you have one solution, okay? One solution, sometimes it's called a repeated root. Okay, you end up with just one answer, which is that answer, you can say repeated root. Okay, so there's one solution there. And when b squared minus 4ac is less than 0, then this becomes negative, and you have the square root of a negative number, which gives you no real solution. So this is where you have 0 real solutions. And that's the case that we are considering now when there are no solutions. Okay, no solutions. Okay, so basically for our case here, there will be no solutions. No solutions when b squared minus 4ac is less than 0. So in this case, our a is the coefficient of x squared, so a is k. b is the coefficient of x, which is negative 4. Be careful, there's a minus with it. And c is the constant, which is just k here. Right, so these, if we put these into the quadratic formula and we set it such that it's less than 0, that will be the inequality that we have to solve to find the set of values of k for which they do not meet. Okay, so here you have b squared, which is minus 4 squared, minus 4 times k times another k, and we have to find when that is less than 0. So that's 16 minus 4k squared is less than 0. So basically our discriminant is, in this case, 16 minus 4k squared. Right, so when the discriminant is positive, there will be two solutions. When the discriminant is 0, there will be just one solution, which means basically that the curve and the line, they're tangents. Okay, when the curve and the line just touch at one place, that's when the line is a tangent to the curve. That's in this case when there's one solution. That's how, if they say find the value of k for which the curve and the line is a tangent to the curve, we would set b squared minus 4ac equal to 0. But in this case, we want to know the case where it doesn't touch it at all, where the line and the curve are totally separate. Okay, so solving this equation will tell us the values of k for which there will be no solution. Okay, because either, as we mentioned, either the curve and the line, either the curve and the line meet in two places, in which case there were two solutions, that's when the discriminant is positive, or they meet in one place where the curve and the line is a tangent to the curve, or they don't meet at all, in which case they don't intersect, and that's where the discriminant is negative. So the discriminant is negative, the discriminant is 0, the discriminant is positive in those three cases. So now we have to solve this inequality. Now to solve a quadratic inequality, what we have to do is first we have to find the critical values. We have to find where does it equal 0. So we take 16 minus 4k squared and we make it equal to 0, and we solve this equation. So to solve this equation, you can simply do 16 is equal to 4k squared and then divide both sides by 4, so you have 4 equals k squared. So k is equal to plus or minus 2. All right, so k is equal to plus or minus 2. So that's where this discriminant hits the k-axis. So what I'm going to do is I'm going to just draw a little graph to illustrate and make things very clear, hopefully. I'm going to draw a graph. This is not a graph of the function. This is a graph of the discriminant. So I've got the discriminant, which is b squared minus 4ac, against k values. Now I know that the discriminant is 0 when k is negative 2 and positive 2. And I know that this is the equation for the discriminant. As we said, it was 16 minus 4k squared. So that means the discriminant, if you were to sketch this, it would look something like this. Something like this. I'm gonna move things around to make it look better later. Okay, so, but what I'm gonna do, forget that. Let me just draw a nice quadratic. You don't have to do this, by the way. This is just for purposes of explaining. Okay, I'll try and draw a quadratic as best as I can. That's minus 2, and that's plus 2, and that's 16. Okay, so this tells us about the discriminant. The discriminant is equal to 16 minus 4k squared. Now, we want to know when the discriminant gives us a value which is less than 0. Okay, which is less than 0. So where we are on the discriminant value is given by the y value of every point, right? So, for example, when x is minus 2 or plus 2, the discriminant value is 0. That's where, okay, that would be the solutions which will tell us where the line and the curve would have tangents, okay, or the line would be a tangent to the curve. When the discriminant value is greater than 0, when it's up here, so when k is between minus 2 and positive 2, the discriminant will be positive, which means there will be two solutions, okay, and when the discriminant is negative, it's when k is less than negative 2. When k is less than negative 2, we'll end up with the negative values for the discriminant. And when k is more than 2, we'll also end up with negative values for the discriminant. So when k is less than -2 and when k is greater than 2, that's when there will be just one, there will be no solutions. Okay, no solutions. Okay, so there'll be no solution. Therefore, the line and curve will not meet. Line and curve. Okay, they'll not meet for those values. Okay, when k is less than -2 or k is greater than 2, those are the range of values for which there will be no solution, which means the line and curve will not meet when k has those values. And that completes the answer to this question number 1 from the end of topic worksheet and also from this paper, October, November 2016. All right, so I hope that was clear. Other questions from this particular paper can be found in the playlist over here. That's for the October, November 2016, paper 1 variant 3. Other questions from my end of topic worksheet that I have answered can be found in the playlist over here. And you can watch all the different questions I've done on quadratics from my Cambridge collection in the playlist. Subscribe to my channel by clicking on this link. Thank you for watching and see you soon.